In this video, we're going to go over the Pythagorean theorem, and we're going to talk about how to use it to solve problems associated with geometry. So let's go over the formula first. So if we have a right triangle, and this side is called A, B, and the hypotenuse is C, then the formula is C squared is equal to A squared plus B squared. C is the hypotenuse, it's the longest of the three sides, and A and B are known as the legs of the right triangle. So let's say if we have a triangle that looks like this. And let's say this side is 5 and this is 12. Calculate the value of x. Now if you want to try it, feel free to pause the video. So let's use the formula C squared is equal to A squared plus B squared. So A can be 5 or 12, it doesn't matter. So let's say if we choose A to be 12 and B is 5. The hypotenuse C is across the box, which is x. So we have x squared is equal to 12 squared plus 5 squared. Now 12 times 12 is 144, and 5 squared is 25. 144 plus 25 is 169. Now to calculate the value of x, we need to take the square root of both sides. The square root of 169 is 13. And so that's how you can calculate the hypotenuse of a right triangle. Now let's work on another example. So let's say the hypotenuse is 10, this is 5, and our goal is to calculate y. Go ahead and do this. So let's use the same formula. C squared is equal to A squared plus B squared. So C is the hypotenuse. So in this problem, C is 10. A, we could say it's y, and then B is 5. So it's going to be 10 squared is equal to y squared plus 5 squared. 10 times 10 is 100, and 5 squared is 25. So we need to subtract both sides by 25. Now 100 minus 25 is 75. So now our next step is to take the square root of both sides. So y is equal to the square root of 75. Now how can we simplify this value to get the right answer, or to get the exact answer in its fully simplified form? What perfect square goes into 75? 25 is the perfect square that goes into it. 25 times 3 is 75. And the square root of 25 is 5. So y is equal to 5 square root 3. Now let's work on some word problems. What is the area of a square with a diagonal length of 12 inches? So first, let's draw a square. And so this is just a rough sketch of a square. And this is the diagonal of the square. So that's 12. Now let's call this x. All four sides of a square are the same, so this is x. So notice that we have a right triangle. The area of a square is the length times the width. Both the length and the width is equal to x. So the area of a square is x squared. So if we can calculate the value of x, we can calculate the area of the square. So let's use the Pythagorean theorem to calculate x. So c squared is equal to a squared plus b squared. C, the hypotenuse, is 12. A is equal to x in this example, and b is equal to x. So 12 squared is x squared plus x squared. 1x squared plus 1x squared is 2x squared. And 12 squared is 144. So first we need to divide both sides by 2. (144) divided by 2 is 72. And so that's equal to x squared. Now let's take the square root of both sides. So x is equal to the square root of 72. Now a is equal to x squared. And x squared is 72, so a is just 72. So that's the area of the square. By the way, if you want to simplify this radical, you can say that 72 is 36 times 2. And the square root of 36 is 6. So x is 6 square root 2. But the area is x squared. And we can see that x squared is 72, which means a is 72 in this example. Number 4. In rhombus ABCD, BE is 7 and CE is 24. Calculate the perimeter of the rhombus. So the first thing you need to know is that the diagonals of a rhombus bisect each other at 90 degrees. BE is 7 and CE is 24. Because the diagonals of a rhombus bisect each other, AE and EC are congruent. BE and ED are congruent. So if BE is 7, ED is 7. And if EC is 24, AE is 24. Now, all four sides of a rhombus are congruent. So let's say if we call this S, this is S, that's S, that's S. So the perimeter is 4S. Now notice that we have four congruent right triangles. This is 7, this is 24, and this is S. So let's use the Pythagorean theorem to calculate S. C squared is equal to A squared plus B squared. In this case, C is the hypotenuse S. A, we could say it's 24, and B is 7. 24 times 24, that's 576. And 7 squared is 49. Now 576 plus 49 is 625. So now let's take the square root of both sides. The square root of 625 is 25. So now we can calculate the perimeter. So it's 4S, or 4 times 25, which is 100. So that's the perimeter for this particular rhombus. It's 100 units. Number 5. What is the area of the isosceles trapezoid shown below? So first we need the formula. The area is 1/2 B1 plus B2 times H. So B1 is the first base, that's 12. B2 is the second base, which is 20. And H is the height of the trapezoid. So somehow we need to calculate H in order to calculate the area. So how can we do so? Now the first thing we need to realize is that for an isosceles trapezoid, AB is congruent to CD. So both sides are equal to 5. Next, we need to draw two right triangles. Now we know that AD is 20. That was given to us in the beginning. Now if we add two additional points, let's call this E and F. EF is the same as BC. That's 12. Now, if these two sides are congruent, and this and that has to be congruent, these two, AE and FD, must be congruent to each other. So if we call this X and X, we could say that X plus 12 plus X is equal to 20. Or 2X plus 12 is equal to 20. So let's subtract both sides by 12. So 20 minus 12 is 8. And if we divide by 2, we can see that X is 4. So we could put a 4 here. So now we can find H, the missing side. So now let's focus on this right triangle. C squared is equal to A squared plus B squared. The hypotenuse is 5. A, we could say it's 4, and B is H. 5 squared is 25, 4 times 4 is 16. And 25 minus 16 is 9. So h squared is 9. And if we take the square root of both sides, we can see that h is equal to 3. So now that we have the value of h, we can calculate the area of the trapezoid using this formula. That is this formula here. So it's going to be 1/2 b1, which is 12, plus b2, which is 20, times the height of 3. Now, 12 plus 20 is 32. And half of 32 is 16. 16 times 3 is 48. So this right here is the answer. That's the area of the trapezoid.